are that we're going to talk about are, let's call them subjective. I'm not entirely sure that they're not 100% subjective, but there is a large element of subjectivity to them, right? Obviously with programming, at the end of the day, whether the computer executes it correctly or not is the arbiter of correctness, you know. So that's another thing. We'll get to that in a minute. But essentially, this is just about, I guess it's about code quality to an extent, but it's really more about how to write code that is easy to change later when you come back to it, really. Like, and ultimately, like for me, I would say that's one of the main metrics of code quality. Like certainly if you work in a group making a game, you want to come back to your code in 3 months' time, or one of your colleagues go in and edit your code, and you want them to be able to do it without pinging you in Slack for 4 hours and asking you silly questions that you hope would be obvious, right? So this talk is about that stuff. Oh, wait, hold on. I need to click on something. There we go. So who am I? I've covered it in brief. I'm technical and design director of Darby Limited, which is my own little company, so I could call myself whatever I like. Grand Poobah, King of the Universe, anything, doesn't really matter. Darbytron's been going since 2014. I've mostly do porting of other people's games to console using, so people who are making a Unity game, they'll call me in and I'll do the console port for them. I've also shipped a game that was original IP, which was called Road to Guangdong, which is like a weird little driving around slowly in a car in China in the 90s game. I really like it. It's a bit weird and quirky. It's sort of like a, I guess, a Coen Brothers movie, but a video game, if that makes any sense to anyone. I don't know, we'll see. Anyway, so what have I been doing? Making video games since the mid-90s. I also used to run a master's course at Gamer Camp in Birmingham City University for about 3 or 4 years, from 2011 to 2014, before I started Darbytron. I was a founding member of a company called Freestyle Games, who they are now Ubisoft Leamington. That was in the early 2000s, and we invented a game called DJ Hero, and that's how we sold our company to Activision off the back of that. I've shipped 19 multi-platform console titles. A lot of those were when I used to work in AAA, so I started off at Codemasters working on Colin McRae Rally, which became Dirt eventually when Colin McRae died and they could no longer use the license, and a bunch of other games. I mean, I've been making games for a very long time. I've done everything, as I said before, from like engine code. I have done graphics code, but it's never been my main job, and certainly physics engines are beyond my mathematical ability. But I've got a very, very broad programming experience, and if you needed to give me a label, I guess it would be technical generalist as a program. I don't know if from, you know, a bit of shader stuff to gameplay code, you know, frameworks, tool chains, everything. And oh yeah, I was the game dev programming here in 2019, but we shouldn't dwell on that. It's just a, you know, award that your peers vote for. Okay, so how to be less awful. Well, the reason I called it that is because I think software engineering is a very complex topic, and I think anybody who tells you there's a correct 100% way to do it, it's probably wrong. And I think what we can do for is, the best we can realistically hope for is to be able to find a way to share our knowledge and experience and help each other avoid risk by avoiding no mistakes. So one of the biggest things, which you may or may not know, about making video games is that everything we do in developmental processes is ultimately about reducing risk, right? Because if we have a risk in a project, it means we're likely to waste time, and if we waste time, we waste money. When you're in a big project, that's how projects slip. And in the old and bad days, and at some companies where they still are that way inclined, you sometimes end up doing crunch because of it, right? So if you can reduce risk, you can make everybody's life easier. You can make sure your game ships on time. You can make sure that milestone payments come from your publisher if you're working for a company that works for a publisher rather than being owned by a publisher. And yeah, so it's good, right? But so games are complex and they change during development. And what that means is that we've got these conflicting software engineering goals. Like when you're at university or doing a programming course, you get taught this idealized view of programming where you can map it all out on post-it notes and design all of your classes and then just write the code and whoops, done. Everybody claps and you make £1 million, right? Like clearly that's not how it works in real life. One of the biggest problems with that approach is that building that much architecture into a project up front means that it can be very difficult to change it to do something else later, right? And these are big book problems. Like, you know, people write whole books about how to correctly structure software and like whether you should do certain language features and like what the side effects of those are and all that sort of stuff. And production methodologies, right? We've got like waterfall, which is bad and evil, and we used to do in the old days, and sort of more and more agile processes that are more sort of human focused, which are good on average. But those are big picture problems. So what I'm talking about is a medium-sized problem, really. And this really, the inspiration for this talk was really that I've seen a lot of almost shipped code bases. So if you imagine when games get ported, it's generally when they're getting towards master, someone calls in, say, we'd like to put this on Xbox or PlayStation or whatever. And I come in and I help them do that. So I've seen a lot of code bases that are theoretically production code, theoretically about to ship. One of the things that you see, and obviously they had very different architectures of code, like the way the front end work might be totally different, the way that the game itself might be built out of prefabs, or it might be built out of lots of multiply loaded scenes, or it might be just one enormous scene with everything in it. I mean, every game's got its own way of doing this stuff. But ultimately, they all suffer from one problem or a class of problems that are very closely related. And these problems usually started really small. Like, so we're talking about a tiny benign like simple code issue that started off as one class and then slowly sort of spread through the whole project and caused problems over time, till at the point when you're trying to ship, it just becomes this nasty mess that nobody wants to go near. And so what I'm calling this is a meso level problem, which is what it's between micro and macro, right? So these medium-sized problems, they're super important when porting, which is one of the reasons why they bug me so much, right? Because it makes my life a lot easier if they don't exist in the code base, but it makes everybody's life a lot easier, right? I think one of the things when you come into a code base towards the ship time for a project is that you don't have that perspective. Everybody else who's been making the game for this whole time knows that this one code file has become horrific and no one wants to go in it, and they all sort of turn a blind eye to it and no one ever refactors it, and it just, you know, if someone has to make a bug fix in there, they sort of poke it and hope it doesn't explode, you know. But on console, that makes my life very difficult because platform requirements are non-negotiable. You know, Microsoft won't go, oh, it's cool, you don't have to pass that rule for that game because we can see that one like code file is horrific and no one knows how it works anymore. So this talk is about how to avoid getting into that place in the first place, really. And hopefully the philosophy that I'm going to expound will help. That's my hope. Yeah, like I said, nobody does this by accident. Like, these horrible broken bits of the code base never happen on purpose. They sort of happen by accident. We're all busy. We're shipping stuff to milestones. And so you never got time to go in and change that one bit of the project, or those 2 or 3 bits of the project that are problematic, because just I've got to add a new feature. I haven't got time to fix it. And also, we know that when the project finishes, we can chuck that bit of code away and never have to look at it again. Next time we write a new game, we won't do it that way because we know better, right? And I think that's one of the weird problems about video games, in that, like, you can train it at university, you can do courses in it, but ultimately, until you've seen a completely broken code base, it's hard to actually understand how bad it can be. And so what passes for career and personal development, which is what CPD passes for in the video game industry, and why people always ask for X number of shipped games, is because that's how you accumulate this knowledge, right? On average, is by shipping games that were broken and then learning how not to break them that same way next time. So what I'm hoping will be the takeaway of this talk is a thing I call minimum viable software engineering. And it's really, I guess you could kind of argue they're coding standards. I'm not going to call them that because they're not the kind of things you write. It's not like, you know, where do you put the spaces between your brackets? You know, has that got to have capital letters in it? Do we put capital C's on the front of classes? All that sort of stuff. It's more about actual things that will break your code or may break your code in the future, and sort of the warning signs that a bit of code is about to get nasty so that you can refactor it before it does, rather than waiting till after it is when it becomes problematic, right? And the idea is that this would help you to address this medium-sized risk problem. And it sounds like, okay, we're doing a game jam, why do we need to know this stuff? Well, part of what we're judging you on is the quality of your code. And part of the point of it is to help you get better at writing code so that when you go to job interviews, you can talk more authoritatively about how to you know, avoid certain problems. And if someone says, well, how did you solve such and such a problem, or pick a problem that you solved that was horrible, hopefully this will give you some more of those things to talk about in your interview, right? And yeah, the idea is to proactively reduce risk so we can avoid these cumulative issues, or at least minimize the side effects of them, right? So I don't pretend to have the whole answer. What this is sort of a start, and it's been an ongoing start. I've added slides to this talk as I've given it over the years, and there's probably a bunch of stuff that I should have added that I have forgotten about that's in the notes on the slides, but we'll see. So the guiding principles of this really are like to take responsibility for stuff. And one of the big things that you, again, probably won't really start to see until you're working on bigger projects with lots of other programmers and artists and people, is that once you put stuff in source control, you have to live with that code, right? Like, and sometimes you get away with it. If it's a bit of code that's out of the way and it's not core to the project, you know, that's fine. But sometimes if, you know, we had some code at Freestyle that when we were writing a graphics engine for PS3 and Xbox 360 and the Wii, we wrote some really simple font code that just rendered a font, and it was the simplest, most horrific, like, array of stuff, quickly draw it to the screen, done. That got committed to the repository. No, we're thinking, well, we'll go back and fix that and make it nice later. We were still using that exact same bit of code with umpteen fixes on top of it when I left Freestyle. That's a bit of a slip of the tongue calling it Codemasters. And when I left Freestyle nearly 10 years later, we were still using that bit of code, right? Because once it's in there and you know it kind of works, it's just changing it is more effort than people want to spend on it. Certainly when you're trying to get stuff done on to a timeline. Now, obviously, I'm going over the same thing a few times, for which I apologize. I hope it doesn't get circular. But yeah, so we take responsibility for stuff and we minimize the risk, right, by making sure the code's easy to understand, easy to change it, easy to debug, right? Because ultimately, one of the biggest things that you're optimizing for minute to minute in your programming life is optimizing for other people and yourself reading that code and understanding it, because the easier it is to understand, the easier it is to change, the less likely people are to put bugs in it when they come back, right? So we're going to talk about using idioms of code which statistically reduce bugs. That's part of it. But also they ideally don't reduce productivity. And the way that they don't reduce productivity is they don't really take any longer than writing the code in a really sort of nasty, hacky way, right? That's the theory. So this is my thought for the day. And it's as true now as it was when he said it, whenever that was. I never met this guy, sadly. He seems like he looks like a bit of a loony, but he's a bit of a genius, and he basically invented function calls, right, this guy. And this quote, as I'm sure you've all read by now, is that all problems in computer science can be solved by a level of indirection. And that's one of the core things to remember about making code that's easy to change, is it never hurts you to have too much indirect. It never hurts you to have another level of indirection to a point. Like once you get to too much and people can't understand the code anymore, then it's a problem. But generally the way that we make things future-proof, quote unquote, is to put a level of indirection on them so we can change whatever's behind the indirection anytime we like, right? So this is a core principle of like object-oriented code, any kind of programming, basically, right? Okay, so this is a point where I normally ask for audience participation. I'm going to look at the Slack chat when I ask this question. No, not Slack chat. I'm talking about Discord. I don't think I can see that while I'm showing my screen. Can I? It's a question.
We can read out questions.
Yeah, do. So it's less of a question, or of a, I'm going to ask what you think the most dangerous thing in your code base is. And if someone could just read them out to me, and I'll offer opinions on how I feel about that, because I do have a specific thing that I think is the most dangerous thing in a code base.
So Shami Seth says loops.
Nah, you wouldn't get very far without loops. I guess if you index them wrong, you can overwrite memory, but they're not inherently dangerous.
We've got Sam Chandler with switch statements.
No, switch statements are your friend. I disagree that they're dangerous. Anyone else?
Gianluca Pomoni with unreadable code.
Well, yeah, that's definitely dangerous. But in and of itself, it's not the thing that causes stuff to crash.
We have TextBox with recursion.
Well, yeah, anything that causes you to run out of stack memory because of recursion isn't great, obviously. But again, it's not the most dangerous thing. I'm talking about something really simple that you see every day and you type probably tens of times a day. I'll tell you, because it's easier than waiting till you get it. It is, hold on, I've pressed the button and nothing has happened. It's the equal sign, right? Nothing crashes unless you assign it, right? Like unless you dereference a null pointer, which obviously you don't do in C#, but in C++ or one of the languages with pointers, unless you dereference a null pointer, it's not dangerous. A pointer that's pointing to memory that has been deleted isn't dangerous until you use it, right? This single sign, the single ASCII character, causes will be the point at which the majority of bugs in your code base happen. I would go as far as to say it's probably 95% of your bugs are caused by this single character, right? Now, obviously, it's not the character itself, it's the code around it. But the reason I say this is because there's a thing called mutability, right? Which I'm sure we all know as programmers means the ability to change a thing, right? So mutation is dangerous. Mutation is what causes crashes. And that assignment operator is how we mutate things. We take one value and we assign a thing from it. And in order to do that assignment, the compiler or the interpreter or whatever has to take what's on one side of the equal sign, evaluate that, and then assign it to the thing on the other side. So given that we know, statistically speaking, that the equal sign causes almost all crashes and almost all nasty bugs, the logical thing to do from a statistical point of view is to maximize the locality of mutability. And what that means is minimize the number of equal signs in your code, or at least the number of places where things are assigned. It sounds kind of mad, right? But I use this as like a core principle of the way that I write code. And the upshot of it is when something goes wrong, there's, because you're not assigning stuff everywhere, it's much, much easier to track down what's actually causing the bug, right? I would say this is the best argument for accessors as opposed to just setting local, if you've got a variable of a class like a member variable and you're just assigning it everywhere by just using variable equals whatever value, I would say that you should be always using an accessor even inside the same class, really, because it just makes it easier to keep track of where it's being assigned, and so it makes it easier to find in the debugger, right? And again, once you've written the accessor, it's really not any slower to type accessor bracket thing than it is to, sorry, not accessor, the setter with the brackets than it is to type the variable and an equal sign, right? But it's safer. Statistically speaking, there's less equal signs in your code, right? I know it sounds daft, but I promise you it actually works as a thing. In fact, I tell you who I got that off originally. John Carmack was the person who originally said that. And then I was like, what are you on about? And then I thought about it and I've been doing it ever since and it works, right? So if people don't know who John Carmack is, he's old and he's got like some questionable opinions, but he was the person who wrote the engine for Doom. So he's like, grandfather of like amazing programming. So the next problem, right, or one of the next, not the next one we come to, there's no hierarchy here really, apart from the equal sign. That's the most dangerous thing. State and conditionals. How many times have we looked through a bit of code and we found a bool that says like is doing something, and then you find another bool that says like is doing something else, and they're both set to true and false in loads of different places, and you're never really sure whether one should be set to true when the other one's false or vice versa, right? As soon as you see multiple bools in the same class, you should be using an enum. If they're in any way, if they're mutually exclusive, you should be using an enum, and there's a couple of reasons for this. One is that like setting, when you name a variable that's a Boolean, right, if you want people to be able to understand what true means, you have to give it a name that's sort of a logical statement, which can be true or false. Often that's very, very difficult. If you just define an enum and set that, you can say exactly what the state is without people having to retroactively work out what something true means, right? And that's by itself, you're making it more readable, and you're telling people by making it an enum that these are mutually exclusive states, right? So when you're looking through code, if you see multiple bools, and you know that this is a sensible rule to follow, you know that those must be not mutually exclusive, and so therefore they can both be true or both be false or whatever, right? And another thing, going back to what somebody else said, switch is not dangerous. Switch is awesome. Like, if-else statements are one of the next most dangerous things after equal statements. And the reason for that is that when you've got an if, then an else, then an else if, and all those, that it's a chain of implicit logic, right? So by the time you get to the second or third if-else, the code that's in there isn't just what's in the if at the top of that block, it's also failing the previous ifs and elses, right? So there's all this implicit logic that sits on top of it, which means that when someone else comes along and tries to understand that code, they're inherently going to have to go through your logical, well, your logic. I mean, it is logic because it works on the computer, but they're going to have to understand that code, right? In order to understand, if you're trying to fix something in the third if else, you have to understand all the code in the previous bits to know what's going on in there, really, because otherwise you can't be sure that you're making the right fix, right? Whereas with the switch, because they're mutually exclusive states, right, and they're an enum, or well, generally, full well that whatever you change in that switch can't possibly be affected by the logic of anything else in the stack, right? So it's safer. Statistically speaking, you have to store less information in your head to decide where the right place to make a change is, right? And here's the thing is, right, if else's don't happen generally, they don't happen in one go. What will happen is usually there's an if, and then there might be an else, and then eventually someone will come along and stick an else if in the middle of that, and it will grow and grow and grow and grow. And like UI code is like the worst place to find this stuff, right? Because nobody ever meant it to be complicated, and nobody wants to spend more time fixing it, but it just ends up that way, right? And I've seen like 1,000-line long if else if statements, and that's not even uncommon. Like that's just how things are. But at some point, there was a point where that if else sprung into an if else, etc. Right? And at that point, somebody could have gone, do you know what? I'm going to make this easy to follow. I'm just going to put an enum, and I'm going to just do a switch. Right? No, not every single situation can be done like that, but I would very, very much recommend that as soon as you see that this bit of code that you're working on is likely to spin into a very complicated if statement, you're better off trying to make it into a switch statement if you can. Right, again, statistically, it's less likely to cause you trouble.
I'd like to say, I worked on UI code literally today that was full of if else instead of switches.
Yeah, it's the worst, right? It's absolutely the worst, and it makes your life difficult, and it will make your life difficult forever until you fix it, right? But again, because it's complicated to understand, it's complicated to change, and so nobody wants to refactor it, right? So it's just, it never starts off bad, it never starts. Nobody made a horrific decision to just do it on purpose right at the beginning. It slowly creeps in because everybody's busy and everybody wants to get stuff done. And so, yes, the next one's duplication. And I guess it's a bit much to put those both onto the same slide, but there's a reason for this. This is stuff that is like fundamental stuff you get taught at university. Well, it's bad to duplicate code. You want to abstract stuff, right? Yeah, it absolutely is. And in general, you want to try to avoid writing the same bit of code twice. Especially you don't want to copy paste code from one place to another generally, for the same reason that we don't want to assign everything in all over the place. As soon as you're copying and pasting code, if the original code you copied and pasted had a subtle bug in it, and then you later fix that and you don't know that it's been copied and pasted somewhere else, that's a bug that's still lurking around in the code base, where if it was a function and it's fixed once, then it's fixed everywhere, right? So again, you do have to be careful with this. Like quite often as programmers, the way our brains are wired, we will see generality in everything, right? Don't get sucked down the rabbit hole of trying to make everything super general. Like there's a point at which you should stop rabbit holing. I can't tell you exactly what that is, you'll find it. But on average, try to avoid writing the same code twice. And if you're copying and pasting something, write a function. That's the rule of thumb, okay? And that's another thing, abstraction, abstract anything likely to change, right? So if I was making a Unity game, which I do frequently, right, I would never call Unity engine.scenemanagement.scenemanager.load ever, or load async. I never call that inline in code. That's wrapped in a function, right? And that function is itself in like a scene manager class. Even if I never do anything more complicated than just call that function, I'm going to wrap it in a little wrapper class like that, because at some point in the future, I might want to come in and completely change how that loading works and put a load of extra state in there and cause loading screens to appear and stuff. If I wrap it in a class, it's trivial to go in and change it. If I put load scene everywhere that I'm loading a scene, suddenly I've got to go and change everywhere that I put load scene when I later realize I need to do it differently, right? So it's not taking you a huge amount of time. You're just going, okay, this is a bit of code that is doing something that I might need to change later. So I'll just put it in a thin abstraction, like literally a function would do it really. It doesn't necessarily need to be a whole class, but like in C#, you can't have a function without a class, right? Well, a classic example of this, for those of you familiar with C++, is that you have to wrap the allocators for new, like you should never really be calling new or delete in a C++ code base. You should have them wrapped with some other function, because then when you need to track allocations, you can just put the allocation tracking into that function and know that you've caught every single new or delete in your entire code base without having to go and find them, right? And that, again, that's the whole point of abstraction, and why I brought up that the way to solve anything in computer science is another layer of abstraction. Hopefully that makes sense. I'm not speaking far too fast. I know I have a habit of doing that, so I apologize if I am. So once we've got all that stuff, assuming that assuming that we agree that stuff isn't complete nonsense stuff I'm talking, and even if we do think that it's nonsense, that's fine. I'm open to discussion. The next thing to talk about, really, I'll list the next thing in my slides, is lifetime visibility and scope. Well, so now one thing you'll find, like if you you're looking for any sample code anywhere on the internet, you're pretty much guaranteed within about 3 seconds to find a lazy initialized singleton suggested, Stack Overflow, like Unity answers anywhere, right? I'm going to go out on a limb and say, do not do lazy initialized singletons. They are the absolute fruit of the devil. And the reason for this is lazy initialized singletons are essentially global data, right? But worse than global data, they're global data that you don't know when it's going to get created and you can't control when it's going to get created, because the second somebody calls the getter for a lazy initialized global, it's instantly created. Now that sounds great because you never have to worry about whether it was created when you call it. But if you're trying to ship a game and your memory layout matters and you're running out of memory and all that sort of stuff, you want to know exactly what's been created and when it's getting removed and why, right? Like those are important things to manage when you've got the limited memory that you have on a console. Well, less so on the newest ones because they've got almost as much memory as a modern PC, but stuff like the Switch, still relatively limited, right? But the important thing is if you do lazy initialization, you don't know when that's getting created. And the reason why you don't know is because it's lazily created, right? But so you think, well, that's fine, we just be careful when we do it. But if you're working in a team, as soon as you make something lazy initialized, there's a non-zero chance that's probably approaching 100% of happening, that somebody will be doing some work right in the boot sequence and they'll go, oh, wouldn't it be cool to just be able to access that thing right now? And suddenly a load of memory is getting created really early that was getting created, later on in the game before. And so if your memory layout changes, there is a chance that your code behavior will change somewhere, or it's less of a problem in C#, if I'm honest, but it still causes trouble. So I would say control your lifetimes. If you've got a manager class that instead of making it lazily initialized, just make it have a create and a destroy function, so that at the beginning of your code you create it and at the end you close it down, so you know exactly who's creating it and when. These sort of things don't sound like they're important, but honestly, when you're trying to ship a game, if you've suddenly got like 4 gig of textures that you didn't know where they came from, and someone, they're getting loaded by a lazy initialized globe singleton thing, and someone suddenly shifts where the first time that's called is, it can cause you all kinds of trouble. Right. Yeah. This is the thing, visibility. And this is the reason, one of the other reasons why singletons are bad, right? Or that sort of pattern in general. The more places that something's visible, the more places it can be interacted with, and the more places its state can change, right? And we covered already right at the beginning that mutability is inherently dangerous. So the more places it can be changed from, the more likely it is to be changed from somewhere else, right? And it just means that like it's harder to track down when things are going wrong and why. So in general, I would say like one of the first things that I was taught when I started doing computer science was that global variables are bad, right? And a singleton is literally a global variable hidden behind the name of a coding pattern. And so it's not to say don't use them, just be very careful about how you use them, right? I've seen so many bugs. The reason I'm going on about this is because I've seen so many shipping blocking bugs caused by lazy initialization or, over singletoning of code. So there we go. That's sort of my rant about singletons over. But so here's another thing that people generally don't think about, is that asynchronous stuff is pretty much standard these days. Like you might not realize it, but there's a lot of places in a modern code base, certainly if you're doing anything on a console, where you can't just go, hey, load that file. Oh, the file's loaded. You have to sort of ask for the file to be loaded and then wait around until it is. And that might not sound like a big problem, but when you're porting a game, again, this is a problem sort of to an extent parochial to porting. When you make a game for Unity on PC, a lot of people use player prefs. I wouldn't use player prefs. It is a bad idea. Use a file, save your data into a file. And ideally, you want to pretend that file access is asynchronous, even if you're just opening it and writing it, pretend it's asynchronous, because that means that then the UI that has to sit around and deal with waiting for the save to happen can deal with the save happening, and all of the rest of the behavior in that front end knows how to deal with asynchronous stuff right from scratch when you write it. Trying to reverse fit asynchronous behavior into a system that expects synchronous behavior is a lot harder. And so, yeah, basically all data IO, you should assume it's asynchronous, right? I'm not talking about like seam loads and stuff, although yeah, sure they are. But stuff like, you know, loading your save game, talking to internet servers are obviously inherently asynchronous. So if you can try to make anywhere that game logic is doing loading or saving or any of that stuff asynchronously aware in the first place, it makes your life a lot easier when you come to make changes to it afterwards, especially if you're moving it between different platforms. And again, this is one of those places where it's very, very simple to just wrap it in a thin layer of indirection that's just like, you know, request load file, has file loaded, file is loaded, okay, cool. Or just put a callback for when the asynchronous operation is finished or whatever. It's relatively straightforward to do it as you go, but retrofitting it afterwards can cause you a lot of trouble. Okay, so we're sort of into the classic, let's talk a little bit about object-oriented code part of it now. That this is the same sort of stuff you'll learn anywhere about object-oriented programming. But the one thing I found is that when you use it in a practical case, you know, when you're using the stuff that you've learned in an academic context, in a practical context with other humans, what you start to realize is that like it becomes incredibly important how you communicate these things, because it's not enough for you to know what a variable name means. Somebody else who reads that code has to be able to understand it without having to try and work it out, because if they have to try and work it out, there's a non-zero chance that they're going to come to the wrong conclusion about how that variable behaves or what that variable does or what that object does. And so they might make assumptions about that based on that incorrect assumption, and then the code all goes out the window and there's bugs and stuff, right? So in things like C++, it's sort of more obvious because you have like const functions and you can pass const pointers and all that sort of stuff. So if you're using const correctly in C++, then it's very obvious whether or not a function is going to change the state of a thing and all those kinds of stuff. But one thing I would say to think about this is there's this thing that people sometimes talk about called self-documenting code. And I'm a big subscriber to this. Like almost every IDE these days has autocomplete. So having a really long variable name or a really long function name that tells you exactly what that variable is or what that function does is not really a problem from a point of view of typing. Like once you've typed that variable name once, everybody else who comes along is going to have autocomplete fill it in for them. So it doesn't matter if it's 40 characters long, right? If it tells you exactly what it does unambiguously, then people who are trying to understand the code won't have so much trouble. And on top of that, the way that you write those names, if you write them so that the code reads a little bit like prose, like sort of, you know, variable distance from player to wall equals get distance to wall player position, you know, that sort of code doesn't take, you don't have to understand, well, theoretically you don't have to spend time understanding that code because it says exactly what it does. Now the downside is if you change how any of those functions work, you've also got to rename them, right? But again, modern code tools have all that refactoring stuff just built in, so take advantage of that. One real code smell that you'll find, and certainly when you're prototyping, this is not something you necessarily have time for, but is this separation of responsibility. So like quite often you've got a class and it's doing something and suddenly you realize that actually it's kind of doing two jobs that are orthogonal, like they're not interrelated, but your class is still doing them. So in theory, we should be splitting that out into two new classes at that point, right? That's what object-oriented programming sort of literature would have you believe. If you can't split it out into a new class, what you should do is stick it all into one region, right? And make it like easy to refactor out later, right? That's again, just the little things that you can do that don't actually take much longer, but just mean that the code becomes a little bit easier to pull apart later when you need to. And when you're doing this sort of thing, especially for UI code, in fact, everything to do with games, when it comes down to it, is pretty much the model view controller. I don't know if it's a pattern. I guess it's a pattern. If you don't know what it is, Google it. It's sort of, we have a model which is the representation of the game's representation. The view is what we show to player with either UI or game graphics or whatever, and the controller is the bit of code that sits in between the two and sort of mediates change, right? And that's a useful thing to know about. I can actually see the chat now, I've just realized.
I was about to bring up the question.
Yeah, how do you separate when something should be separated? Well, that is a good question, and it's not always obvious, but like basically, if you've got two sets of variables and the code for those variables, and those variables are never used in, wait a minute, what am I trying to say? If you've got a bunch of variables that have functions that operate on them, right? And then you're adding new variables and new functions that operate on those new variables, but the new variables don't operate on the old variables, and the old variables, sorry, the old functions don't operate on the old variables, and the old functions don't operate on the new variables, then they're sort of two separate bits of code, right? And so that's sort of where the responsibilities are. Like as soon as you realize that the thing that was responsible for keeping control of game state is also keeping track of whether the controller's plugged in, like maybe you should separate the controller plugging code out into a controller manager instead, right? Again, that's just an example off the top of my head. It's probably a terrible example. That's responsibility separation is really a thing that you have to do by learning. Like everybody writes accidental behemoth classes. Once a class gets really big, there's a very good chance that it's doing some number of things rather than one thing. It's doing like a bunch of things. And the reason that can be dangerous is if a bit of code is doing a bunch of things, that means that you can have, it's really hard to explain without drawing all over a whiteboard. But it's essentially, it comes to that same problem of like visibility of data and keeping track of mutability. Like if you've got one big class that has a lot of internal data and a lot of functions that sort of do different things, then you could call a function that you think is just loading a file, but it might actually be setting a load of game state as well, right? And that's where you start to get these problems. And the honest answer is, like I say, you kind of, it's not easy to explain when that happens. You'll just sort of start to get a feel for it the more you do it. I hope that makes sense.
I think there's a little bit of an argument for like when you write a new piece of code, just ask yourself the question, is this really the right object to handle?
Yeah, absolutely. Yeah, there you go.
Should
Josh
this
is on the
thing
money.
be responsible for it, or should it really be something else?
Yeah,
I think there's also part of this ties into to how things are named, right? So like when I think back about the enormous kind of monolithic classes that I've seen in projects before, they're usually called something like game manager, right? Like this very, very general name, which kind of means that it sort of feels like like it's an okay place to shove lots and lots of things. Whereas if you have much more specific names about, you know, like I guess you can have manager classes, but you want to in the name specify a much more limited kind of responsibility for it, which helps to kind of remind you, like, hey, maybe this stuff that I'm adding to this, you know, player states manager, which is a more limited thing, maybe this thing that I'm adding to that is actually not part of that.
And that's an incredibly good point, Steve. Actually, you're right. It's almost always like the you know, game manager, or another really obvious one is like not user data, sorry, like, you know, settings manager or something. You know, if it's broad, then you're going to put stuff in it and assume it's okay. So specific naming, I think that's all. I'm going to add that to my slides from now on, in fact.
Nice.
It definitely needs to go in there, because well, this is the funny thing about it's like a cheesy thing that you see in like fantasy literature, but like they say, our names have got power, but names genuinely do have power. Like Steve just demonstrated that names have power, because when you read a name, it instantly in your brain will make a bunch of associations and lead you to a conclusion. Now, if that conclusion is wrong, then bad things can happen, right? Or, well, even if it's right, bad things can happen. But yeah, I spend way too much time naming things. So, well, maybe don't spend too much. Maybe I'll worry about it too much. But I give this as an argument that you could worry way too little as well, right? So I think that handles it. So bewaring the object-oriented rabbit hole, like this is one of those things where, like, I said right early on in the talk, right in the first couple of slides probably, that, you know, OP has taught us this front-loaded design process. The problem with that is it tends heavily toward over-engineering and falling foul of assumptions, because until you start writing the code, you don't know what your assumptions are until you actually go, oh God, that thing doesn't have that function. I thought I could do that. This, you know, matrices don't quite work that way, or, oh, the transform doesn't let me do that. Suddenly you're gonna have to change the way you code it, right? So what I would say generally is like Steve was saying, you know, ask yourself, does this belong in another class? Josh was saying that as well, actually. You know, does this logically, what this doing a different name than what this class is doing, right? Should I put it somewhere else? But that's probably about as far as you need to go. Start writing the code, and if you find that it's getting a bit tangly, think, okay, cool, how do I separate this out? Does it need to be 2 classes? But think that as soon as you notice that it's getting a bit difficult to work with, rather than just going, oh, it's fine, I don't have time now. Because 9 times out of 10, that little bit of extra time you spend now will save you hours and hours and hours in the future, right? That's the really key thing about all of these little rules of thumb. Another thing, which again is really contrary to what you're taught, I've come across so many circumstances where abstracting behavior into a base class has actually caused so much more work than just not abstracting that behavior into a base class. Because the further back you sort of abstract the behavior down this column of classes, the more weird, the more like special case code you need in those base classes to allow the classes that are derived from it to behave correctly. So it can cause all kinds of trouble. Like narrow, deep inheritance hierarchies are definitely a code smell. Like if you start to have like things inherited from things, inherited from things, probably over relying on inheritance and likely to bump up against problems with it later. It's not to say you shouldn't abstract things into base classes, you absolutely should. And again, this is one of those sort of can't tell whether or not it was a bad idea sometimes until after you did it. In fact, the number of times I've gone, oh yeah, that should definitely be a base class, have done it, and then about a week later I've gone, oh God, I wish I hadn't done that. Now I've got to write a whole load of special case code in the base class instead of in the derived class. So yeah, this is a lot of these things come down to just experience. I would say that in general, composition and is the best way to solve these problems, especially in stuff like UI. Interfaces are like they obviously exist in C++, but in C#, they're actually like a thing that's separate from types. Interfaces are incredibly powerful for stuff like UI because they imply nothing about the internal behavior of a class, just that it can do this specific set of things which you might want, right? So, you know, if you've got a bunch of really different objects in your game that you need to be able to show in the inventory of your game, for example, then all you need to be able to do is to have an interface for inventory object that can get you like a description of it and a picture of it to put in the inventory and a sort of version of that thing as the inventory version of it, which you can put in a list and keep in your inventory. The actual classes are probably completely unrelated apart from the fact that they want to go in the inventory. Whereas the sort of classic approach to doing that would be like anything that you have derives from thing that I can store in my inventory. Like that way leads to madness, I promise, having been that way myself more than once. So yeah, composition, in case you're not sure, is to basically take member objects and combine them to create the behavior instead of inheriting them in. Takes a bit more typing, right? But that's really the only downside to it. It takes more typing when you write the class in the first place, but actually the knock-ons that you get in terms of having to refactor and change stuff are much less when you have composition. Certainly I've come across problems that were literally unsolvable because of my class hierarchy, and I had to refactor the class hierarchy to fix them. And you don't tend to get that with composition at all. And again, there's very compelling arguments for it. If you look on the internet, you can find statistical analysis of like what happens if you do, you know, this particular, there's like some, like at the beginning of the article is, oh, we'll just define this problem that you've got to solve, and it's got this, this, and this. And this is one of those classical, like, you know, all shapes are shapes, and then we've got a circle and a triangle and a square, and they will derive from shape, sort of things that you get taught at university. And they go through, well, what if you did it with composition, and what if you did it with inheritance? And they show all the ways you would need to, all the places you would need to make changes if you did it one way and if you did it the other, and actually composition comes out better on pretty much every metric. So I don't have a link, but definitely Google about that, because it's a thing that can make you a much better programmer, or at least make you happier. I think probably. So patterns is another thing, like that I feel like we should talk about a little bit. How long have I taken? Way too long already, or not? I can stop or slow down. Why do you want 20 or 30? Say I can speed up. Oh no, I think I'm sort of at the end of the list of sort of heuristics now. Anyway, so I'll just quickly talk about design patterns. They're very, very, very much worth knowing about, because they're really good shorthand for discussing like ways of solving problems with other programmers. The one thing you definitely need to be careful of is just going, oh, cool, that's a so-and-so out of the pattern book, I'm going to do it that way. Generally not a good idea. You want to just only use as much complexity to solve a problem as you need. If you're implementing a pattern out of a book that you know of, 9 times out of 10, you're probably going to be using slightly more complexity than you actually require. This is another one to Google if you want a wide range of opinions. There's at least as many people advocating that they are the fix to everything as people saying they're the spawn of the devil. So read up on them. But yeah, just be aware that applying patterns, don't see them as solutions looking for a problem to fit them to. That's kind of the wrong way, right? But they're very, very useful to know about as a grab bag of potential solutions. Okay, so my sort of approach to writing code, and again, this is sort of like, rather than doing things to make a load of post-it notes in architecture way, basically, have a quick think about it, write down an incrementally ordered list of like, if I do this thing, then I can do this thing, then I can do this thing, right? And the important thing is that each one of these bullet points wants to be like incremental and testable. So you can do a bit and then know that that works, and do a bit more and know that that works, right? Just get it working as fast as you can, right? That's the next step. That will show you where your assumptions were bad. Because if you spend, it's very easy to spend way too long on the thinking about it stage and then have accidentally made a bad assumption right at the beginning and waste a load of time, right? Don't be scared to throw away code when you're just in this like smashing things together phase, because you'll still learn from it. But then once you know it works, refactor it into a state where you know you can come back and change it more easily next time, right? A thing that I do, which I guess is a little bit idiosyncratic, but I quite often put curly brackets with no if or anything on the top of them, just to make sure that they limit the visibility of local variables in functions. If I've got quite a lot of, say you've got quite a lot of maths, and you don't want to accidentally use a variable you were calculating further up the function, but it doesn't make sense to split it. Local scopes can help you make code that's easier to refactor, because they avoid you accidentally reusing variables all over the place. I would also avoid using member. If you've got a case in your code where you're using a member variable like a function parameter, right, instead of to capture the state of the system, don't do that. Just pass it around like a function parameter, because then it's visible. As soon as things are invisible or harder to see, they become harder to debug. Iterate on it until it's good, until you feel like it's good enough to commit. Like if you want to have like a little, think of the most picky programmer you work with and think, if I check it in like this, are they going to moan at me, right? If you're doing it by yourself, obviously that's tricky. Things will change later. And if you know that there's shortcomings in your code, just put a comment there and say like, yeah, I know this isn't ideal. I've done it this way for now. Again, stick it inside a function or something so that it can be changed later without it being difficult. And yeah, so we take personal responsibility. That's one of the key things that I was talking about, is like, that really means refactoring now. Like if you notice it's got 2 responsibilities, split it now. Why not now? Like don't do it tomorrow. And if you're not doing it now, at least make a note of the places where you know your code needs fixing, right? So I use Trello for everything personally, like, or when I'm working for bigger companies, we have like proper producers and Jira and stuff. But I always keep track of technical debt. Like I've usually got a whiteboard on my desk, one of many, that's got all of the things that I know I need to do that aren't quite right in a bit of code as I go along through it. And then before I check it in, I'll go through and make sure that I've looked at them. Just little things, right, that can make your life and everybody else's life easier. I talked about self-documenting code. One of the reasons for this, one of the biggest reasons for trying to structure your code and write it so that it reads easily, is that basically whenever you put a comment in, if your comment isn't explaining like why a bit of maths looks scary, or this function needs to be called before that function, probably it's a comment that's going to end up stale You know, if you come in and change the code, it's very uncommon for people to go through and fix all the comments. Like, so in an old code base, you'll find comments that literally say different stuff to what the code is doing. And at that point where you think, well, you know, is the comment wrong or is the code incorrect given the comment? Like, you could, I guess you could go back through source control and see which one was written most recently, but you know, that's a kind of extreme solution. So I would say on average, your comments want to be why and how, not what. If you're commenting what your code is doing as opposed to why it's doing it or how it's doing it, you probably don't need that comment. You're probably just better off naming your variable so that it tells you exactly what it is, and naming your function so it tells you exactly what it does, right? Okay, so pointing to consoles, we've talked about that already. It's not super important. If you want to talk to me about pointing to consoles, hit me up in the Discord. I've got a separate talk about pointing to consoles. I could just post the slides to that in the Discord. Yeah, so one thing I would say about pointing to consoles is like Unity, awesome, been my main source of income for the best part of 10 years now. Unity works on everything. Right? I don't need to worry about porting because Unity runs on the Xbox, on the PlayStation. Not exactly true, right? Like Unity does totally work on those, and you will get your game running on that hardware within a couple of hours after getting all of the right bits of hardware and all of the right libraries and stuff. However, getting your game running is nowhere near the whole story. You know, you have to pass all these rules. Like when your controller runs out of batteries or gets disconnected, it has to pop up the right dialogue messages. None of that stuff is Unity's responsibility, right? That's all your responsibility. It's not engine code, it's game code. So that is the biggest amount of stuff that you have to do when you're porting, and all of this stuff that I've talked about will make your life easier if you ever come to do that. Okay. Again, you know, track all of your state explicitly, right? Don't use, you know, is floor further away than 3 and lives equals 4, you know. Like if you are doing that test somewhere, set it to a specific state or a variable that says like player is now in danger of completely dying or something, right? Because otherwise people have to look at that bit of code and go, well, what do they mean by floor is further away than 5? You know, well, in fact, actually having the number 5 in your code without any explanation is in itself a thing you shouldn't be doing, right? You know, if it's a meaningful constant, it should have a name, not just a number. Blah, 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 blah. What are we looking at? Oh, yeah. So when we're doing console stuff, again, this is all specific to console stuff. So we don't need to cover that right now. Okay, code reviews. Right. So this is the thing. If you're working in teams, which I don't know if you are, I assume this is all personal stuff. If it's in teams, then whatever. But I think that you could do that's worthwhile doing is you can show your code to other people. And like when people are looking at your code, or when you're looking at any code you didn't write, if you're saying to yourself, what the flip, when you see a line of code, that's a sign that maybe it could be easier to understand, right? Or that maybe that code isn't doing something. Quite often, when you look at a line of code that looks completely ridiculous, you read a little bit more and you're like, oh, okay, fine, I see what you're doing there, right? So every time WTF occurs to you looking through some code you don't know, if you subsequently understand it and it's fine, that cancels it out, right? So basically, you count the number of times where you didn't go, okay, that makes sense, by how long it took you to read through the code, and that is your WTFs per minute, right? And we've used this as a real like code quality thing, like an informal one, but it seems to work, right? But just because, you know, there's no specific WTFs per minute that is great or bad, just the higher it is, the worse that it might be. Do you know what I mean? And you'll find that between a bunch of people reviewing each other's code, you come to an understanding of where that level is. Okay, so done. Last slide, almost. The last slide is just me saying questions, right? But so essentially the summary, the mantra of this thing is you want to make your life easier by reducing risk. You know, take responsibility for doing things right the first time you do them, not, oh, don't worry, I'll do that next week. Because, you know, next week you'll be busy with something else. So minimize your code duplication, localize where you're changing stuff, always be explicit with what you're doing. Don't go stuck down the rabbit hole. Assume asynchronous for any kind of input or output, and don't put off refactoring, because if it's committed, you will have to live with it. And that is the end. There's some extra slidey bits, but I mean, this is all in the presentation, and I will post these slides as well. So please do ask questions if indeed you have them. Otherwise it gets a bit awkward.
There's that awkward little bit of quiet right at the end.
Yeah, I should unshare my screen, really, shouldn't I? How do I do that? Oh yeah, there we go. Find it. Stop share.
Come back right in.
There we go.
There's some elevator music.
I keep meaning to get some of them ready for our Discord stages, but
that would be hilarious. Oh wow, my light levels in here are clearly all over the place. I think it's zooming in and out. Hold on, there we go. At least stable light now.
Bright.
Well, sorry, hold on. Better?
There we go. That's a good stance.
Yeah, that's from when I was a B-boy. I was never a B-boy. I did make a game. I made a game about B-boys, actually. Sorry. Okay.
Nice. Just about to say we have a couple of questions come through. Why do I get comments like I need to improve my code readability?
Okay, so Shami, without seeing your code, I can't really tell you why. Like, I would assume that if other people are having trouble reading it, then there is something about the way that you think that is different to the way that that person thinks. With this stuff, there's like a normalization time to working in a group that you just sort of get used to what other people will understand. I don't know, show it to other people and ask them specifically why they find it hard to follow. And then you could take that as feedback and improve. Like, again, you can hit me up in the Discord for code reviews. I can't promise that I'm going to just be able to do them. Like, I will try to help. But that's the sort of thing.
The community is also there as well. Like, if you want to like pop some sections of code in and just write something like, hey guys, I've been getting a lot of questions saying like, people are finding my code hard to read. Can anyone go over it and how, basically, like, what can I do better? How can I improve? That kind of thing. So feel free to kind of put yourself out there a little bit. That's the best way you grow.
There are Discords as well for individual programming languages. I'm on the C++ include subreddit, and if you post a question there, within 10 seconds you've got an answer, or you've got 10. And
super dedicated.
Talk about
like,
tiny little details.
Yeah. C++ is like, I mean, I more or less learned to program. I learned to program in BASIC, but I studied C++ had just come out when I went to uni. So it's sort of like my first, let's call it my first language. C# is like a second language that I've learned afterwards, but C++ is a Baroque monstrosity. Like, it really is. There's so many ways to write code that looks completely safe and will run, but will crash instantly if anybody looks sideways at the computer or like eats an apple within 6 feet of it. It's but again, it can be beautiful, like all code, if you're careful, right?
Send us your code snippets.
Yeah.
We'll review them.
Do we write docs? I would say I hardly ever write documentation. The code should be readable, right? Like, I mean, I know the code should be readable. It's an easy thing to say. It's something you must try to do. It doesn't just happen. So yeah, if you've got magic numbers, the magic numbers should be constants. The constants should have a name that describes exactly what they are, not what the number the magic number is set to is irrelevant. It's what it means that matters, right? Same reason you use enums instead of bools. It's like, you can be explicit. Steve, opinion?
Yeah, I was actually just gonna loop back to the discussion about the previous thing in terms of like code readability and code reviews. Like it does sound like that Shami needs some more specific feedback, and that can be a really scary process, right? Like putting your code out there, knowing that you're kind of doing so with the purpose of it being critiqued, criticized even by other people, and that sort of, I guess, level of technical vulnerability could be kind of scary. But I think it's a massively important part of what this job is, right? Like if you are going to have a career writing code, you're going to be almost certainly doing that in some kind of team environment. You may have kind of formal code reviews as part of your commit process. You may be in a place that doesn't have that, but you're like, other people are going to see your code. They are going to find problems in your code. They are going to have opinions about it. And being able to sort of develop that attitude of like, it's okay to be wrong, and it's okay to use that feedback to try to kind of improve. Like this, I am wrong about things on a daily basis.
Yeah, everybody should
be. And that's
be.
really exciting to me because it means that I'm learning something.
Yeah, it's the exact same with learning art as well. Like, the only way you're going to improve is by putting a bunch of your game art out there. And if you're getting a lot of comments like, oh, my proportions aren't right or something, like you got to keep, putting your stuff out there and asking people questions and getting tips.
On an emotional level, it can be kind of just a scary thing. I mean, the same with that, right? To put yourself out and to kind of have other people like pick holes in that, but it's
you have to separate, like, it's not an attack on your creative ability. It's like, that people are genuinely trying to help, and if sometimes you're doing things wrong, then it needs to be pointed out quickly, and that's you can learn from that.
There's a very big difference as well between new information and additional information. If you think about receiving new information, you're probably going to think, oh, well, the thing I used to do was wrong, so I should do this new information and I should do this all the time. But coding, as Alex's talk is very much centered around, there's no one right way to do everything, and there's no one right way for code to be readable. Everybody has their own, thought processes. So instead of thinking about it as a one new information, think about every comment you get as additional information to supplement your ability to make code readable for a wide array of people.
Yeah, Josh is absolutely right. That's literally the way to think about it. Code review, like Steve says, I'm completely with you. It's funny, like you learn to just be, you have to sort of learn to remove your ego from code. Like once it's written, it's not your code, it is code that is in the project, right? And I mean, you might have been the one that wrote it, and it's very hard not to feel that ownership, but you just got to take a step away from it and remove yourself emotionally from that, because even the code you're most happy with, it might be proudest of, might have a load of bugs in it that you didn't see because you just didn't notice them. It is what it is.
And the motivation for constant improvement is that even if you have managed to remove yourself emotionally from that code, on a practical level, if there are issues with it, people, a week, 2 weeks, 6 months, a year down the line are going to be coming back to you to talk about that code.
Yeah.
And the answer then is not about justifying why it was written the way that it was. It was about kind of going, okay, let's investigate what I did wrong. Like, let's investigate what the problem was and fix it, right? Because we've got games to ship.
Yeah. And on the just real quick to fit in, just on the subject of time, because we're coming up to about an hour and a half, we'll probably take maybe a couple more questions and then start to wrap up, just so these lovely people can go and have their
absolutely dinners. I need to make dinner for my family as well. So I think the last one at the bottom is like, what's a good solution for the global accessible simultaneous problem? So in and of itself, that this question is like, but I know people who are like absolute purists and like literally there is no singleton in my code base, and there are lots of solutions to that. Like if you care enough to be that worried about it, like there's things called dependency injection frameworks, which are a way to get around singletons, right? And that's this whole thing. Read up on them, they're interesting. I'm not necessarily saying I don't use them. It's not to say that I wouldn't in certain circumstances. They're good for automated testing and stuff like that. That's another reason actually why singletons are bad, is because the more globally accessible a thing is, the more places other code can reach it. So if you want to make your code automated, if you want to do code testing automation, you have to sort of be able to write code that exists and can be tested by itself without needing everything in the whole universe of your code base to work. When you use a singleton, that essentially is saying, here's the thing that all of my code might need. And so there's a tendency to accidentally make code harder to test because of that. But so the answer to it is really, there is, you can't, singletons are fine. You just have to be careful. Like when you use them, you just have to have like discipline and take responsibility not to include stuff everywhere, and don't just shove data into the singleton because it's more convenient than passing it through a function or whatever. That's where it comes down to it, right? It's like singletons aren't fundamentally bad. Like, so the way that I solve this in my own games is I have one singleton, which is to go back to what Steve was saying, a bad thing called the game manager. But in my code, the game manager is literally like a registry of services that are available, like modules. So like the save game manager is available through the game manager, and it's not a singleton, but there is only one of it, and you get at it through the game manager, right? And so it's just about sort of compartmentalizing and stuff. Like the danger isn't singletons themselves, it's the bad things that can happen when you use them too much. And again, it's hard to explain exactly what that looks like when it's bad without showing you a code base and trying to get you to fix some bugs in it, if you see what I mean. It's a practice thing, but I would say trying to avoid them rather than just go, yeah, singletons are great, is a good way to start.
Cool. Oh, very thorough answer. Wow. Oh, that's great. So it looks like that was probably our last question then. But that being said, if you do think of anything or have any questions about the design challenge, I will be posting this all up in the Discord afterwards. And if you want to go back to anything that was said in the presentation, Alex, you said you were going to post up the slides.
I will, yeah. I'll share the slides in the Discord, and I'll also do my one about console porting as well. I don't think that's got anything NDA related in it, so it should be safe to put on there.
Yeah,
it's really just
quick go over it first, just to.
I'm sure it's fine. I've already shared them publicly on the interweb, so I'm sure it's fine.
All right, and then we'll have this recorded as well to pop out as soon as possible.
Yeah, takes a little while to process sometimes, but like this evening or tomorrow or something, I'll get the link up in this.
Awesome.
As a quick last thing, back to the topic, make a grappling hook. I'm sure everybody here would encourage everybody to start talking about ideas together in the Code Technical channel. Let the Code Technical channel be almost an open forum for your inner monologue on what you're thinking about doing for this. Because gameplay programming is such a fun thing, and it is so much more fun when you do it with other people and show people what you're doing.
I can't wait to be watching the channel this evening and see all your crazy ideas going off. Like, there's probably like some awesome, like amazing stuff you could do with grapple hooks. Like, as part of the brief, we've also included some like attached inspirational media, like examples of grapple hooks that Steve has amazingly put together for you guys. So make sure to go through those and just like
didn't make the videos. I just found.
Well, yeah, but you did the research part for us. But yeah, make sure you go through those and like start kind of brainstorming some really crazy ideas. And as Josh said, just start chatting to people, chatting about them, see what works. Yeah. So to wrap things up, you've got 2 weeks from today. On the 14th, submissions will be closed at midnight, I guess, on that day. So until then, the submission processes, you'll be emailing me essentially all your bits. And all the details for that will be included in the PDF, which I'm just about to drop into the Discord. So cool. Thank you so much for coming along, everyone. Good luck with all your challenges. Thank you for coming here. Hope you got something really good out of it. And also just a really big thank you to Alex, Steve, and Josh for putting so much effort into all this to come and help you guys out. So woo, thank you.
Thank you, Alex. That talk was incredible.
That's what, I'm glad you liked it. It's sort of the distilled contents of my brain from 25 years of programming games, so I mean there's so much, like it's one of these things I could literally talk to you till you are unable to stay awake about it. I'm sure I'd love to in fact talk to everybody about it forever.